Hello everyone, I'm Brooke and I work on an ACR funded project. Jason Condon's the lead and we're based in southern Vietnam. So we're using these chameleon soil moisture sensors, which is a very simplified version of everything that everyone else before me has talked about, to change the farmer practice. So the Focus project, we're looking at growing alternative crops to rice in the Mekong Delta during the dry season. There's saline intrusion, so the rice is dying. We need to find dry season crops that are both tolerant of drought and saline conditions. Historically, in these areas, farmers have grown rice, and that's up to 3 rice crops a year. They're very good at irrigating rice crops, so lots of water. We needed a cheap, easy to use, and I emphasise cheap, we're in southern Vietnam, a device that we can educate farmers that they don't need to irrigate these upland crops like they do their rice crops. And that's where we came across these chameleon soil moisture sensors. These are developed by Richard Sturt from CSIRO, now sold by the Virtual Irrigation Academy. They were developed for use in southern Africa, so affordability, practicality was a forefront in their design. They measure matrix potential, but they do it through a traffic light system. So you don't get a number, you get a colour. And each colour there, the blue, the red, corresponds to the 3 soil moisture sensors here that you can put at any depth you want, provided it's the depth of the cord. So don't go 2 metres. They show real-time data, and these loggers here send this to a cloud via Wi-Fi. Most farmers in Vietnam, believe it or not, have incredible Wi-Fi, unlike Australia. So that's really cool, and they can see it as their crops change and rainfall and irrigation. So we've taken these over to Vietnam, and the one issue we are finding is they're inhibited, obviously, by high levels of soil salinity. Where that number is, we're working on that. So the colour system, you have the kilopascals, and it just is a range, and it links to that. So the blue light is 0 to minus 22. Minus 22 to 50 is green, which we're saying is good standard farmer practice. And red, we're saying now you go and irrigate. Understanding there are limitations to this depending on crop type, but this is where it is at the moment. These can be displayed depending on the moisture at that depth. So this will change depending on where the soil moisture is. Field applications. These were designed, and as is on the website, to be put at depth. Example here, 5, 10 and 15 centimetres. We're dealing with upland crops in quite shallow root zones, so we've actually spread them spatially, which has meant we get more bang for our buck in that each sensor can go in a different treatment and crop. How we're using it in our field trials in Vietnam is a farmer practice, so they irrigate as they know and as they want, and we try to keep that away from what we're actually doing. So most of the time, to give you an example, it's irrigation every day. We then compare that to a chameleon with no straw, and then straw of different tons. And we have found some pretty cool results. The chameleon almost halves the amount of water that farmers apply compared to farmer practice, but it doesn't just come to water use. There's minimal yield compromise with that, but it's the labour component. So they have the same problems we do here. Everyone's moving out of the delta, there's less people to do the labour, but also they spend so much time watering, they're not focusing on the actual crop agronomy. So bringing watering back to 4 to 5, nearly once a week, it's pretty cool stuff. So this is the stuff that you get on the online where it's sending it to the cloud. This is time series, obviously. The blue is meaning it's wet. As it dries out, you see the pattern of green to red, and then whatever irrigation or rainfall. And you can customise this pretty well, adding crop. If there is salt limitations, it will come up as a purple error bar sort of there. And so this is per Wi-Fi sensor. There is a card version. This is cheaper, but it doesn't log data continuously. So probably a research option and a farmer option. That's the sort of thing that we're looking at. So you need to, you have the same arrays and you just touch it and hold the light, and that's how you get that. The farmers, this is one of our farmers here, they really love that because of the colour system. They can walk around, they can have multiple arrays. So it works quite well. The benefits for the farmers, it allows us and them to create an irrigation schedule based on quantitative data, not just on historical ways of which they've been taught to farm, which is rice. So through that, we're instigating management practice change and, most importantly, saving irrigation water in an area that, you know, it's the dry season. Improve water use efficiency and the potential decreased application of saline irrigation water out of the canals. There are other studies that have found exactly the same of what we're finding. Tanzania, places like that, Rich has done plenty of work. The sort of, one of the things that we didn't expect but is really important is the saving on labour and the community and social engagement. So you put one of these in the field, everyone in the neighbouring farms wants to come and see. And so we're getting this practice change from farmers that we've trained how to use them, and they're starting to do these good management practices, and then they're teaching the next farmer. So it's this flow-on effect that's beyond just the physical science that we're capturing, and we're looking to capture that data. So that's what we're using in the project. There's still a lot to develop, still a lot to learn, and I know they're being used in Bangladesh and other places on similar ACR projects, so it's exciting to see them being used in more areas like this. So, yeah, that's me. Thank you very much, and yeah.